Hey guys, what's up? So today we're going to be looking at the binary system, okay? So we're going to be looking at binary. And let's just read this paragraph here. In the binary system or decimal system, we count in base 2 and use the two digits 0 and 1. So these are the two numbers that we use, right? Since the number base or scale is 2, each digit in a number has a place value in terms of powers of 2. And the number 111001 to the base 2 can be represented as, all right, what can it be represented as? We're going to write it out. We're going to do it in this case, okay? All right, guys, so we're going to call this first row here the group size, okay? And then we're going to call down here the digit, okay? Or the representation of what digit it's supposed to be, okay? So we're gonna write out the 1, 1, 1, 0, 0, and 1, right? Okay, so the first one, it's in terms of powers of 2, right? Just like the decimal system. So the first one would be 2 to the 0, right? And the next one would be 2 to the 1. Next one would be 2 to the 2. The next one would be 2 to the 3. The next would be 2 to the 4. And this would be 2 to the 5. Okay. All right. So let's kind of reduce the size here. So for this one actually represents 1 times 2 to the 5, right? And 2 to the 5 is actually 2, 4, 8, 16, 32, right? So this is 1 times 32, okay? So that's what that represents. This one would be 2 to the 4 is actually 16, so it's 1 times 16. Then this one, 2 to the 3 is actually 8, so it's 1 times 8. Cool. Then this one is 2 to the 2 is 4, so it would be 0 times 4, so that would end up with 0. And then 2 to the 1 is 2, which would be 2 times 0, which is times 2, and then this 2 to the 0, anything to the 0 is equal to 1, so this would be 1 times 1. So the total, we're going to put over here, let's write total, right? The total of the bottom row here should be 32 plus 16 plus 18, no, sorry, plus 16 plus 8 plus 0, that 4 would be 0 plus 0 plus 1, okay? So the total is actually 57, and that's what you should get in the decimal system, all right? So 111001 to the base 2 is actually equal to 57 in the base 10, okay? So it's just like the decimal system in that each digit in a number has a place value in terms of the powers of 2. So it's always going to be starting from 2 to the 0 to 2 to the 1 to 2 to the 2 to 2 to the 3 to 2 to the 4 to 2 to the 5. All right. So let's do another example. All right, guys. So we're going to look at some other examples. Let's look at a small binary number. Let's look at 101 to the base 2. All right. So this would be equal to, let's start with 2 to the 0 times 1, which is the first one, which is this here. Then the next space would be 2 to the 1 times 0 plus the next space, which would be 2 to the 2 times 1. All right, so you'd end up with 4 here. 2 to the 2 is 4 plus 2 times 0, which would give you 0, plus 1 times 1. So the answer for that is actually 4 plus 1, which is equal to 5, all right, to the base 10. So 101 in the base 2 is actually the same thing as 5 in the base 10, okay? 5, just a normal number 5 that we'll always use, all right? So let's look at another example. Let's look at a decimal example, right? Meaning we're going to look at decimals in binary now. All right, guys. So let's look at a decimal let's look at a decimal, right? Meaning the decimal representation of a binary number. Meaning it's basically a decimal number. Okay. So we're going to look at it, and what do these represent? It's still in terms of powers of 2, right? So the first one would actually be 0 times 2 to the 0, okay, which is this space here. Then the next one would be 1 times 2 to the negative 1 plus 1 times 2 to the negative 2 plus 1 times, no, not 1, 0, sorry, which is this 0 here, times 2 to the negative 3 plus 1, which is that 1 there, 1 times 2 to the negative 4, okay? So this would actually end up being 0, this would be 0, plus 1 times 2 to the negative 1 is actually a half, so it's 1 over 2, plus 1 over 4, plus this one would end up being 0, plus 1 over 16. Okay, so if we write these out as decimals, we're going to get 0.5. Let's remove the zeros because we don't need them. So we're going to get 0.5 plus 0.25, right? Plus 0.0625. Okay, so when we add all of these, we're actually going to get 0.8125 to the base 10. So 0.1101 to the base 2 is actually equal to 0.8125 in base 10. All right. Cool. So let's look at one that has normal binary numbers and numbers across the decimal point as well. Let's look at another example. All right, guys, great. So let's look at this example now. All right. So we have the first. This is another binary number, and we need to find the answer. Would say, what is this number in base 10? Okay. So you need to find this number in base 10. All right, which is in the decimal system, all right, or the denary system. So you need to change it to base 10, all right. So for the first thing here, we're going to use the same thing, all right. We're going to look at the group. The group is 0 and 1, right? So it's base 2. And then we're going to start off here, okay, with these numbers. So this one would be 1 times 2 to the naught, okay, which is 1. It's the same thing as 1. Then the next one would be 0 times 2 to the 1 plus 0 times 2 to the 2 plus 1, right, which is this one now, times 2 to the 3 plus 1 again, 1 times 2 to the 4 plus 1 times 2 to the 5. And if you notice, it's the same example we used earlier. So we're going to end up with the same number, 57. All right, and then let's look at these now, which are also place values in terms of the powers of 2, right? So to add this one now, it would be, you're going from 0 to negative 1, so it would be 1 times 2 to the negative 1 plus 1 times, this one is 1 times 2 to the negative 2 plus 0, this 0 here, times 2 to the negative 3 plus 1 times 2 to the negative 4, okay, which is this one here. And this part is also the same example we did earlier too. So actually supposed to end up with, this would be 1 plus 0, this would be 0 plus 0 plus 2 to the 3 would be 8, so this would be 8, right? Plus 16 plus 32. And then this part here now, it would be, let's add the decimal part, it would be 0.5 plus 0.25 plus 0 plus 0.0625. All right. So the answer now, when we add all of these in base 10, the answer should be 57.8125. All right, in base 10. So that's how you convert from binary to decimal with the point, right? With the decimal point, all right, or the decimal point in this case. All right, and yeah, it's great, guys. It's wonderful, and thank you so much for following along. It's a little difficult, but we're gonna do some examples in the notes. All right, and I'll see you in the next lecture. In the next lecture, we're gonna convert from base 10 to base 2. So we're gonna change stuff from decimal to binary. Okay. All right, guys. So that's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.